Hello students, today we are going to learn electricity part 2. So yesterday we learned about the differences between primary cells and secondary cells. Finally we winded up. When we stepped into the concept of electrons and the charges carried with the electron, okay. So the electrons, they are negatively charged particles in outside the atom, which is revolving around the nucleus. It has a negative charge and the value it is represented as minus E because it is a negatively charged body, and the value of the charge will be 1.6 into 10 to the power of minus 19 coulomb. Okay. So yesterday we were seeing this point, is it not? If n electrons pass through a cross section, imagine cross section of a conductor. Okay, cross section means it is only a thickness. That's why I drawn this diagram. You consider a copper wire. Imagine there are n number of electrons. So n number of electrons are passing through the wire in time t seconds. So what will be the total charge? So the total charge passed will be given by the formula Q is equal to n into E, because n will be the number of electrons and E is the electron itself. So Q is equal to n into E. And you know the formula I is equal to Q by T. Instead of Q, you will substitute as n into E. Okay, it's an important formula. Therefore, we learned that I is equal to Q by T is 1 coulomb by 1 second or 1 ampere. 1 coulomb by second is also called as ampere. So, 1 ampere is equal to 1 coulomb per second. Now, shall we define 1 ampere? So, what is 1 ampere? So, current is said to be 1 ampere if 1 coulomb of charge passes through the conductor in 1 second. So again, what you do, yesterday only I told you have to see the formula and learn. Okay, current is said to be 1 ampere if 1 coulomb of charge passes through the conductor in 1 second. Now, let us consider, suppose a question arises in your mind. How many electrons are there in 1 coulomb? Okay, how many electrons are there in 1 coulomb? So we can learn the value, but before learning the value, let us have a small derivation. So you know the formula Q is equal to n into E, or n is equal to Q by E. So 1 coulomb, here I told it is 1 coulomb. So 1 by, what is the value of E is 1.6 into 10 to the power of minus 19 coulomb. Okay. So which is that 1 coulomb, see here 1 coulomb and coulomb can get cancelled. So you will have the value as 1 by 1.6 into 10 to the power of minus 19. Now what I do, I keep this 1 by 1.6 in one side and I just shift this 10 to the power of 19 minus 19 to the numerator. So it becomes 10 to the power of plus 19. Now again 1 by 1.6 can be written as 10 by 16. You know mathematical values. So how to do mathematically? So 1 by 1.6 can be written as 10 by 16 into 10 to the power of 19. Just divide 10 by 16 either by simplification or a division method. You will get exactly the value as 0.625 into 10 to the power of 19. See here 0.625 into 10 to the power of 19. So instead of writing, we have to write the number of electrons. So this is not okay. So what we will do is just shift this decimal instead of 0.625, shift this decimal to 6.25, and there the exponent will be reduced to one number. So it becomes 10 to the power of 18. So 6.25 into 10 to the power of 18 electrons. So you got the answer. So what was the question we were having in our mind? How many electrons are there in 1 coulomb? So in 1 coulomb, how many electrons are there? It's a very important question. 6.25 into 10 to the power of 18 electrons in 1 second. Okay. So let us, I have created a table here. So 1 coulomb will have 6.25 into 10 to the power of 18 electrons in 1 second. Suppose I ask a question, how many electrons are there in 5 coulomb in 1 second? Then you can just write it as 5 into 6.25 into 10 to the power of 18. If there are 3 coulomb, what will be the number of electrons in 3 coulomb? So 3 into 6.25 into 10 to the power of 18. How many electrons are there in 8 coulomb? 8 into 6.25 into 10 to the power of 18 electrons. Okay. So now let us, okay, 10 to the power of 18 electrons. Now let us consider the subunits of ampere. You know ampere is a SI unit of current. So weak current, sometimes the instrument may show some weak low currents. Okay, so that also can be measured in smaller units. That is 1 milliampere is equal to 10 to the power of minus 3 ampere, and 1 microampere is equal to 10 to the power of minus 6 ampere. This also you better learn. Sometimes a 2-mark question can arise from here. Okay, so with this we are stopping with we are completing the concept of charge on electrons. Next we are going to a very interesting concept, easy and very reachable to you. Okay, so it is about insulators and conductors. Hope you would have learnt about insulators and conductors in your lower classes. So let us have a fast look. What is the meaning of what are insulators and conductors? Okay, substances which do not allow current to flow through them are called as insulators. They have almost no free electrons. Already I explained yesterday. All the metals are good conductors of electricity. Why? Because they are having free electrons. Copper will have the maximum number of free electrons. Therefore, the free electrons will be free to move from one atom to another atom. Therefore, they are used in conducting the electricity. But here in case of insulators, so look at the point. They have almost no free electrons. Next, it offers very high resistance to the flow of current. Example, rubber, plastic, wood, asbestos, etc. So you got the idea about insulators. So what are insulators? Substances which do not allow current to flow through them. Examples also we are given. Now let us understand what are conductors. This is very easy for you. Substances which allow current to flow through them easily are called as conductors. So what are the characteristics of conductors? They have large number of free electrons. Okay, they offers very small resistance to the flow of current. Yesterday we learned the concept of resistance. What is the meaning of resistance? Is obstructing or stopping. But here in conductors it will have very small resistance. That means the current flow will be more. Okay, the best example is human body. Don't you agree? Human body is a very good conductor of electricity, because you know that how people get shocks also, because current is flowing through the body. Okay, now human body, all metals such as copper, aluminium, silver, etc. So this is idea about insulators and conductors. Okay, now let us go to the very interesting concept, that is circuit. Have you heard about the word circuit? It's very easy. Look at the diagram here. I have drawn the diagram. The path along which the current flows is called as circuit. And always in the external circuit, current will flow from positive terminal towards the negative terminal. Okay, if current flows in the circuit, it is complete or closed. So if current is flowing through the circuit, see, look at the symbol for the bulb. The bulb is glowing. I have given a symbol. That means what? The circuit is complete or it is closed. Look at this symbol. This is a switch. So it is closed absolutely. So that means the switch is on and the circuit is complete. Okay. Now let us see the other point. If the current does not flow in the circuit, what is it called? It becomes incomplete. If current does not flow in the circuit, it becomes incomplete, or you can even call it as open circuit. So now we are discussing about closed circuit and open circuit. Okay, I'm having 3 diagrams here. Let us from this we will understand what is open circuit also. Let us view these 3 circuits carefully. See the first diagram. Is it closed or not? If it is closed, the bulb is glowing. Okay, look at the symbol here. So already it is closed, therefore the bulb is glowing and it is a closed circuit. Now see the second diagram clearly. See, the switch is off. That means it is open. There is a small gap. And see whether the bulb is glowing or not. The bulb is not glowing. That means the circuit is incomplete, or it is also called as open circuit. Now see the third diagram. Here everything is okay. Everything is closed. But look at that red color part. So that red color part is not made of copper wire. It is made of thread, ordinary twine thread. So will it become a closed circuit? No, it cannot. It will become an open circuit. What may be the reason? Because thread is not a good conductor of electricity. So from this, what will you understand? Very important point. The circuit becomes complete only when each component of it must pass current through. Each component means every part of the circuit should be good conductor and it should allow the current to make them flow. Then only you can call it as a closed circuit. Okay. If there is an insulator in the path, here what is the insulator? Thread acts as the insulator. Okay. If there is an insulator in the path, the circuit is open and current will not flow through it. Okay. So I hope you have understood the concept of closed circuit and open circuit. We have 3 diagrams also. Very interesting and easy to score marks. Okay. Now we are coming to the point, that is next topic, which is called as potential difference. Okay. After I explain potential difference, you are going to understand about, yesterday I told you that I am going to explain conventional current and electron current in the later part. So while I am explaining potential difference only, you will understand what is the meaning of conventional current and electron current. Okay, I will explain clearly. Now I want you to see the diagram. There are two bodies, A and B. B is uncharged. B is an uncharged conductor and A is absolutely a positively charged conductor. Before you tell the answer, I want you to understand. So what do you mean by positively charged conductor? Yesterday we saw, whenever you say positively charged conductor, that means the number of electrons will be very less. And this is uncharged. What do you mean by uncharged? So the uncharged conductor means it will consist of equal number of some amount of electrons. But when you compare these two, body A and body B will have better number of electrons than body A. So what happens? The electrons will flow from B to A. Did you understand? So electrons will flow from B to A. Even though B is an uncharged conductor, electrons will flow from B to A because B consists of some amount of electrons. Next diagram here. Again, you are having two bodies. A is negatively charged body and B is uncharged conductor again. So now you compare please, where A will have, where the number of electrons will be more, the body A will have more number of electrons than body B. Why? Because even though this is uncharged conductor, but B is absolutely a negatively charged body, therefore the number of electrons will be more compared to A. Therefore the electrons will flow from A to B. Now let us come to the third diagram. See, this is very easy. A is absolutely negatively charged body, B is positively charged body. So from where the electrons will flow? Electrons will flow from A to B. Okay. So did you understand? Now, so from the above examples, what is coming to your mind? From the above examples, it is very clear that one region is a region of excess electron and the other region is a deficit. So what do you mean by deficit? Means poor region of electron, excess region and poor region. Instead of poor, you are using the word deficit. Okay, this condition actually is created in an electric cell. So you are using a battery. So consider a dry cell or a battery. What is happening? One region, you are having two ends. Yesterday we saw, is it not? One is a positive electrode, positive terminal. The other one is a negative terminal, which is consisting of a positive electrode and a negative electrode. So one end is always having an excess number of electron. The other region is always having a deficit region. This condition is always created in electric cell. As long as this condition is maintained, the electric cell keeps on, we can keep on drawing current from the electric cell. Okay. So this is the concept here. So what happens inside, a chemical reaction takes place within the cell. So in an electric cell, flow of electrons in an external circuit is from cathode to anode. So that also is clear for you. Now let us understand about, this is an interesting part for you, very little difficult in the beginning maybe to understand, but once you get the point it will be easy. Okay, so you are going to learn about conventional current and electron current. Two things we are going to learn. So before we learn conventional current and electron current, let us consider three cases. See children, case 1, I am keeping a ball and just dropping the ball to the ground. So what happens? The ball will fall from a height, from a higher region towards the lower region. Next, what I am doing, I am having a second diagram. You can see two vessels are there and there is a small connecting tube. Okay, but the vessel A is having maximum, the height of the water level is more compared to the vessel B. So automatically the water will flow from a high pressure region towards the low pressure region. Now case 3, look at case 3. There are two bodies. Body A is at a higher temperature, maybe 80 degrees Celsius. Body B is at a lower temperature, 40 degrees Celsius. Then how will the heat flow? The heat flow will be from body A to body B. So from this, what did you understand? From this, what did you understand? So by nature, by law of nature, we know that a body falls from due to gravitational force, it falls from a height and it falls down. And what happens, the water also will flow from a higher region towards the lower region. Heat is transferred from a higher temperature towards the lower temperature. Same way what we do, we believe that current will always flow from higher potential to lower potential. So that is a concept, there is a twisting point here. So we believe that it is flowing from higher potential to lower potential. So that is the meaning of conventional current. Because the word conventional, don't get confused, some students will be getting confused with the word conventional current. So conventional means what? Conventional means it is a standard value, or it is a general thing which happens, which is based on some facts. That's the meaning of conventional. Okay. So according to conventional current, what did I explain now? The current will flow from higher potential to lower potential. So let us understand. So this is again, there is a twist here. So let me explain here clearly. Okay. So a conductor having an excess electron is said to be negative. Look at this point, very important. A conductor having an excess electron is said to be at negative potential, which is called as lower potential. A conductor having deficit electrons is said to be positive potential, or which is at a higher potential. Here there is a twist coming. Okay. So the negative potential, negative potential is considered to be lower potential, but what about the number of electrons? It is more. Positive potential is said to be at a higher potential, but the number of electrons are less. Okay. So now we will understand the meaning of electron current. So according to electron current, what happens? Electrons will always flow from the excess region towards the deficit region. So how we have to say electron current? It always flows from lower potential towards the higher potential. This makes the difference between conventional current and electron current. Did you understand? So please be careful while you are writing the definitions or doing the problems. Please be very, very careful. Lower potential means what is that? It refers to excess electron region. Higher potential refers to deficit electron region. Okay. Either you understand that way or understand with positive potential and negative potential. Now, I want you to answer. As I am explaining, you should tell the answer. So, A is a positively charged body. B is a negatively charged body. Now, tell me how the electrons will flow according to your knowledge. According to electron current, how always the electrons will flow from excess region, B to A according to electron current. But according to your belief, what will you say? Always electrons will be flowing from lower potential towards higher potential. So I hope you have understood the meaning of what is it? Higher potential, lower potential, and electron current and conventional current. So once again, we will see here. Look at this diagram. So the body A is considered to be positively charged body. See, deficit electrons, but it is at the higher potential. Then B, body B, you see, negatively charged conductor, excess electrons, but it is at lower potential. That's what I told. Flow of electrons will be from B to A, but electric current will be from, electric current means conventional current will be from A to B. Did you understand? Okay. Now, I want to give an exercise for you. Small question. Now, you see this diagram. Tell me clearly. So, where is B? B is at the lower potential. Okay. But lower potential, but excess region of electron. Now you see B is at the higher potential but deficit region of electron. Now tell me the flow of electrons. From where electrons will flow? Electron current. I want you to mention electron current. So electron current or flow of electrons will be from A to B. But according to the belief, according to the standard value, we will always consider the electric current will flow from positive to or a higher potential towards the lower potential. Did you understand? So this is the concept, and always you understand that the conventional current will be always in a direction opposite to electron current, or the electron current will be always opposite to the conventional current. So there is a numerical problem here for your understanding. I am considering two bodies A and B. Okay. So it is the charge maintenance Q is equal to minus 10 coulomb, and volt is 5 volt only. Here charge is 5 coulomb. Volt potential is V is equal to 10 volt. Now please tell me which is at a lower potential. See, this is lower potential, but it is excess region of electron. This is higher potential, deficit region of electron. Now tell me flow of electrons. From where electrons will flow. So is it not A to B? Check it up. Flow of electrons I have written here. A is at a lower potential. You can, for your understanding, I have written. A is at a lower potential 5 volt. B is at a higher potential 10 volt. So electrons will flow from A to B. So what will be the flow of current? That means conventional current just opposite. Just now I told the conventional current will be always opposite to the electron current. Therefore it is exactly flow. It will be moving from B to A, that is higher potential, towards lower potential. Okay. So with this we will come to a conclusion with this topic, and children, always I end the topic with assignments. Okay. So assignment 2 will be page number 193. question number 18 to question number 22. Please learn thoroughly. So worked examples 1, 2, 3, that also please solve, page 192. So I repeat, assignment 2, page 193, question number 18 to 22, and worked example 1, 2, 3, page 192. With this I am coming to a conclusion, coming to an end to this part. So next class we will learn more about potential difference. I have only given an idea. So next class we will learn more. Okay, thank you children.